We're about to start doing elimination, and the whole point of that is to do row operations to manipulate a matrix into an echelon form. To begin with, all we really need is the relaxed row echelon form. This means get into these two criteria. What I'm about to show you, though, I'm going to get it into strict row echelon form. I don't have to do that, but for me, it turns out I think it's a little bit more convenient because it eliminates some fraction arithmetic. It's the only reason I'm doing it, because everything I'm about to say, we could have done it to get it into relaxed row echelon. One thing I should say, because I did this earlier, this guy is, there's a pivot and there's a pivot, no all zero rows. So it's in row echelon form. But the two pivot columns are here. It has a zero there and here. But this guy is not a zero, so it is not in reduced row echelon. It's just in strict row echelon form. Anyhow, now let's get to solving an equation. And this is very mechanical, not theoretical. You've seen it in my NMath A course. We had a system of equations. In fact, I think it's 261, 121. Yeah, same system of equations. We augmented the matrix by slipping in the B side on the right side of this matrix. So we're operating on the augmented matrix. These little symbols here tell you what the row operation was, and I do only one row operation per step in this example. You can do multiple operations in a given step if you know what you're doing. And what is it I want to do? Since I want strict row echelon form, I want my pivots to be ones. And anything below a pivot, I want to be a zero. So I kind of want to start at the top left and slowly eliminate, make zeros below that. The first thing I'll do here, because this guy's already a one, I'll just swap top two rows. So I now have a one here. There's a good one pivot. Now what will I do? That's all I did going from there to there. Now I want to get rid of this two, and then I want to get rid of that five. I'll do it in two different steps. But to get rid of this two, I want to make it a zero. I'll multiply this top row by two and then subtract it from this row. When I do that, I get this. The top row stays the same, the bottom row stays the same. The only change was this second row. Now I'll do the same thing to get rid of this five. I'll take this first row, multiply it by five, and subtract it by this. So now the first row stays the same from here. The second row stays the same from here. I have a new third row. Because I personally want strict row echelon form. I'll divide the second row by two to make this a one. So there I have that. And now what I want to do, I got all zeros here. There's a pivot, there's a pivot. I want this guy to be zero. So now that this guy is a one, I don't have to mess with, I would have had fraction arithmetic if I left them as a two. I'll multiply this row by three and add it to this bottom row. Top two rows stay the same, the bottom row stays that, or the bottom row does not stay the same. It becomes this. Second row stays the same. And now I'll multiply by 2 11s to make this a 1. All right? This guy is in strict row echelon form. And what does that mean? Remember, the x doesn't change. It's the same x. It's the same x here. I'm only kind of changing the A and B parts. So this represents a system of equations with the same x's in the same order. So this top equation means that. The second equation means that. This bottom equation just means x3 equals 5. That's like when we did it the old-fashioned. Now we have one of the three variables unambiguously defined. It's a 5. Once we have that guy, I've got x3, now I can find x2 from this equation. And once I have both of them, I can find x1 from this equation. Those last few steps are called back substitution. And all this stuff up here to get to here was called Gaussian elimination. If I keep on going, now I want to get zeros up here, zeros above my pivots. I still do the same kind of row operations, but I'm kind of working upward now. I'm not going to go through this. You finally get to this. This guy is in reduced row echelon form. In this case, no all zero rows. The pivots are all ones. Each one is to the right of the pivot above it. And everything else in a pivot row is 0. And now you can just read off the solution. Don't have to do any back substitution. So we use Gaussian elimination to get it into row echelon form, and Gauss-Jordan elimination to get it into reduced row echelon form. These are the two big tools we can use over and over again for a lot of reasons. It's very mechanical. The theory came before that. And it's all that was in my NMath A course.